Okay, we're going to, oops, are we on? Check, 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 testing, testing. Okay. All right. Okay, awesome. Thank you. Okay, we're ready to start our second session here on Astronomy Reveals Creation, as it does. And this is near and dear to my heart as an astrophysicist. And it's I find it painful, I find it a shame that astronomy has been misused by secularists to try and persuade people that the Bible is not true. We're taught the universe exploded into existence 13.8 billion years ago, that stars just kind of formed, planets formed, and around one of them life evolved, and there you go. But I've found that the secrets of the cosmos confirm the Bible, not a Big Bang, not the billions of years. And so we're going to take a look at four secrets of the cosmos that confirm the Bible, and they are the glory of God. We're going to see that the glory of God is built into his universe. It reflects his glory, as the Bible teaches. We're going to see that the Bible is right about the basics of astronomy. There are certain things the Bible teaches about astronomy that are true and would be confirmed in any astronomy textbook. And we're going to see that the Bible is right about those. We're going to see that the Bible is right about the age of the universe. It does have something to say about that topic, and it's right, and the evidence is consistent with that. And then we're going to see that the Bible is right about the uniqueness of Earth. Earth is not just another planet. It is very special in God's plan, and the nature of the Earth reflects that. So let's dive right in and see how the glory of God is revealed in creation. That's something we would expect based on Psalm 19:1. The heavens declare the glory of God. The skies proclaim the work of his hands. That beautiful synonymous parallelism where God is saying something using different words. He's saying the same thing, basically the same thing twice. And there are many ways in which the universe declares God's glory. I'm just going to talk about two: the size of the universe and the beauty of the universe. They are consistent with it being the reflection of God's thinking, his creative activity. Now, the beauty of the universe, you certainly don't have to be an astrophysicist to appreciate that. You can go outside on a clear night, look up and see the beautiful Milky Way and the moon and the stars. It's really stunning. And of course, we are very blessed to live in a time where we have access to things like the Hubble telescope and now the James Webb Space Telescope. And the beauty of these things as we look deeper into space, it is absolutely magnificent. So there's no doubt about that. The size of the universe, that's hard to comprehend. And I dare say none of us really comprehend it. There are good techniques by which we can measure distances to things in space, and the answers we get are just outrageous. It's bigger than what any of us would have thought would have been possible. The ancients had no idea. And even now, we've just perhaps scratched the surface. Galaxies go out a lot farther than what the James Webb Space Telescope, many of the secular advocates were expecting. But what I can do is compare certain things in space to other things and give you kind of a feel for the scale of things in the universe. And we'll start with the moon. This is the smallest and closest thing we'll look at. And it is the moon's about the size of the United States. If you were to put the United States at the same distance as the moon, it would cover about the same area. And if you say, well, yeah, but I can cover it up with my finger, that's because it's 240,000 miles away. And that gives you a feel for 240,000 miles. That's the way the United States would look at that distance. That gives you a feel for it. Really amazing. The moon is fun to look at in a small telescope, especially when it's in the first quarter phase where you can see the craters. This is full moon. It doesn't look quite as good, but this is actually a mosaic image made up of many smaller images taken by the Lunar Reconnaissance Orbiter, which was orbiting the moon, taking high-resolution images of the surface. So that's what you're seeing there. And a lot of times when I show people the moon through a telescope for the first time, the first response is, wow, because it is amazing. It is stunning. And then the second question is, can you see the flag that the astronauts plant? No, you can't see that. This is the size of the United States. Okay, even when we zoom in on it, the smallest features you're seeing are several miles across. But that being said, with these spacecraft that are orbiting the moon, they've mapped it so precisely we can see where the astronauts have landed. Isn't that interesting? And I want to show you one of these. This is Mare Tranquillitatis. This is where the first moon landing was. It means sea of tranquility. They used to think that those large dark areas were seas. They're not. They're basalt rock, but they still retain the Latin name, Maria, which means seas. And as we zoom in on this is the area where the Apollo astronauts landed. Continue to zoom in on that. It's kind of amazing. It really is big. And one more time, ought to get us there. And there is the location. There's the lower portion of the lunar module you see there in the middle. Remember when they landed on that spider-like looking structure, that's the lunar module. When they launched only the top portion to save fuel. So the lower portion's still there. That's what you're seeing there. And then there's some other instruments they left on the surface. And then those dark streaks that you see going over to that crater and back, those are the footprints of the astronauts. They're still there. Isn't that amazing? And the moon is dusty, and there's no atmosphere. So the footprints just stay. There's no maid service. So the footprints are going to be there for a very, very long time. So I find that remarkable. And we've mapped all the sites where the astronauts have landed. So there you go. Yeah, we really did land on the moon. There it is. There it is. And they made that up too. Actually, the Japanese spacecraft have confirmed that as well. And if the Americans hadn't really done it, the Japanese would have called us out on it, right? So there you go. So there's what the moon looks like in first quarter phase. That's when it's best to look at, when it's illuminated right down the middle, because then you can see the shadows of those craters, and it's stunning. And it's interesting too, because your brain, especially when you zoom in on a portion of it, your brain immediately realizes that's a sphere. Based on the way the light interacts with those craters, your brain figures it out that's spherical, which is amazing because that's quite a geometrical computation. And somehow the software that God's put in your brain is able to figure it out like that. Pretty neat. So you have built-in trigonometry in your brain somehow. Pretty neat. Here's the moon compared to the Earth, just to give you a feel for it. So we got a big planet. And we do. If you've ever driven through Kansas, you know we live on a big planet. It is really big, right? Yeah, I've done it too. You're like, does this ever end? Yeah. But the Earth really is pretty small compared to other things in space, like Saturn. There's Earth compared to Saturn. And astronomy is such a lesson in perspective, because when I look at Saturn in a telescope, it looks like it's about that big. It's beautiful, and you can see the rings, and it's stunning, and it's this little gem. You just want to grab it and stick it in your pocket and take it home with you, but you can't because it's 9 Earths across. And that's just the planet. The rings extend even further out into space. The rings are trillions of tiny little moonlets orbiting around Saturn's equator, and they give it that beautiful, beautiful appearance. So there you go. And you say, well, we got some big planets in our solar system, even bigger than Earth, and that's true, but Saturn's small compared to the Sun. The Sun is over 100 Earths across. And again, you can say, yeah, but I can block it with my finger. That's because it's 93 million miles away. And I think that's interesting. The moon, 240,000 miles away. That I can kind of comprehend. 240,000 miles. Some of you, if you have a really good car, might have 240,000 miles on it. You could have driven, there you go. You could have driven to the moon, but probably not back. I'll bet none of you could do it both ways. The sun's 93 million miles. None of you have a car with that kind of mileage on it. So there you go. Now the sun is a star, or stars are suns, if you will. They're the same kind of object. And it's made out of gas, hydrogen gas, and it's held together by its own gravity. Yes, gas has gravity. You have enough of it, it'll stick together like that. And these other stars, those little points of light you see in the night sky, those are suns. And you might think, well, they look tiny. They're either much smaller than the sun or much further away, and most of them are much further away. The sun is larger than most stars, some of the nearby stars. Gliese 674, Proxima Centauri, Wolf 359, those are all smaller than the sun. So the sun is larger than average. You say, well, we got a really big star. But there are bigger stars, like Mintaka, which is one of the stars of Orion's belt. You know, those 3 stars you see in the winter, they're like in a straight line, that's Orion's belt. So Alnitak, Alnilam, Mintaka. Mintaka is the one on the right. So it's a blue supergiant, quite a bit bigger and brighter than the sun. Stunning. There are stars bigger than Mintaka, like Canopus. Isn't that interesting? I don't think you can see that from Tennessee, but when I was living in Texas for a while, it's kind of far south, so you have to be in one of the southern states to see that. But it's a white supergiant. Stunning. Look how big the sun is now compared to that. And remember, the Earth's 100 times smaller than the sun. Yeah. And there are stars bigger than Canopus, like Antares, for example. Isn't that astonishing? Antares is over 600 suns across. Amazing. In fact, if we were to take Antares and put it where the sun is, we would be inside it. It would completely engulf the inner planets all the way out almost to Jupiter. Really amazing. So that gives you a feel for how big the solar system is. The solar system, all the classical planets, could be contained in a box that is 6 billion miles on a side. So if you want to picture 6 billion miles, that's the solar system. Pretty amazing. Now, the next largest object out there, even if we go 10 times bigger, to 60 billion miles, so the solar system is now in that little box in the center. There's not much at that scale. We got even further. There's not a whole lot at that scale. That's getting us about to the scale of the nebulae. This is a nebula. Nebula is a Latin word meaning cloud, but because they look kind of like clouds, but they're clouds not of water vapor, but of hydrogen gas. So made of the same stuff as the sun, but whereas the sun is compact, a nebula is spread out over a vast region of space, hundreds of times bigger than our solar system. There's different types of nebulae. This one's called a planetary nebula, and that has nothing, it actually has nothing to do with planets, it's just a name. And with a planetary nebula, it's produced by a star. There's a star in the middle of that thing. You can see it there, barely in the middle, right dead center. And that star has ejected the outer layers of its gas and formed that beautiful structure. And because the gas is hot, it glows. You get I love looking at nebulae. I never get tired of it. They are stunning. But this is the smallest, one of the smallest nebulae I could find. Most of them are quite a bit bigger than that. This is the Joel-Bug Nebula. Another one that's quite a bit larger is the Ring Nebula. And that one you can see in a small telescope. This is one of the first objects I learned how to find when I was a youngster looking out with my dad's telescope. I'm like, oh, look at that. And it looks like this little glowing smoke ring in space. It's so weird. You don't see the color very much with your eyes because at night you're using primarily your rods, which are not color sensitive. But if you take a picture of it, the colors pop out, and it's really neat. So again, there's a star in the middle. Now this star has collapsed in on itself and become a white dwarf. So it's that little spot you see in the middle. And it's ejected the outer layers of its gas, a very gentle process. Now the neat thing about the Ring Nebula is it's got a convenient size. It's about 1 light year across. And I mention that because you hear that term light year and people think year. They think that means long times. It doesn't. It means it's big. A light year is a distance, and it's a distance of 5.88 trillion miles. That's how big that thing is. So it dwarfs our solar system. Our solar system wouldn't even show up on that image. So that gives you a feel for how big things are in space. So when we talk about a light year, that's how big it is. There are other planetary nebulae. Some of them have a two-lobed structure. We think the gas is channeled out the north and south poles of the star by a accretion disk around it. And so they have that bipolar structure. They're beautiful. I believe that's the Ant Head Nebula. But there are other, these are all planetary nebula. They're the smallest type. There are nebulae that are much bigger than that. This one, for example, that's the Horsehead Nebula. I have seen that, but it's hard to see because it's very reddish and your rods don't pick up red very well. You need a pretty decent sized telescope to see it, but I have seen it and it is wonderful to look at. Now, there's the most of the nebula right there. That's about 22 light years across. This is a diffuse nebula. It's not produced by one star. It's probably original gas that God created back during the creation week, and it's just still there. And if there are stars nearby, they'll cause it to glow. And if there are not stars nearby, it'll be black, it'll be dark. So what you're seeing is bright gas and then dark gas in front of it that's obscuring some of the gas behind. So that's where the Horsehead is. It's the dark gas that's not glowing, at least not very brightly. But there are objects much bigger than nebulae, like star clusters. Look at this guy. I love these things. This is a globular star cluster. There are two types of star clusters, open clusters and globulars. I love globulars. There's about 100,000 stars in that image, in that little sphere there. And that's maybe 50 to 100 light years across. And I love looking at globular clusters. You can see these in a small telescope. You can even see them faintly in binoculars, but they look like a little fuzzy spot in binoculars. But you put a telescope on it and you see hundreds of thousands of stars. And of course, the Bible says he calls them all by their names. God has a name for each one of those stars in that cluster. There's a few hundred of these that you can see. They're all in the summer sky, with one exception. They're all in the summer sky. And that was one of the first indications that we're not in the center of our galaxy. Because in the summer, you're looking towards the center of the galaxy, and most globulars are closer to the center, only one's further out. But anyway, all of these things that we've looked at, planets and moons and stars and nebulae and clusters, are part of a much, much larger object called a galaxy. So what you're seeing there is a collection of about 100 billion stars. So many that they kind of blur together, and it's hard to pick out individual stars. In fact, when these were first discovered, they didn't know what they were. They thought maybe they were nebulae, clouds of gas. And in older textbooks, you'll see spiral nebulae. That's not what they are. They're galaxies. There's hundreds of billions of stars. And it wasn't until the better telescopes were developed that we could start seeing individual stars in these galaxies and recognizing, wow, we live in a structure like that. This is a different one. We don't have a picture of ours from the outside because we can't get outside. We don't have a long enough selfie stick to get a picture of our own galaxy, right? But we think ours looks like that. There are various measurements that allow us to do that. Beautiful. Different kinds of galaxies. Some are spiral, some are elliptical. A few are irregular, but most of them are either spiral or elliptical. Galaxies come in clusters. This is Stephan's quintet. 5 major galaxies. There's some smaller ones in there too. And I've seen this in my telescope. It's really neat. It's very faint, but it's beautiful. There's actually 4 galaxies that are at about the same distance. They're actually part of the cluster. And then there's one galaxy that's much closer to you. And it's the blue one. The blue one is photobombing the other ones. So eventually it won't be, but that'll take a while. So there you go. As we go even deeper into space, you find galaxies upon galaxies upon galaxies. These are not individual stars. Each one of those little specks you see there is a galaxy. Each one of those might have 100 billion stars in it. Some more, some less. And this was a little bit of a surprise. This is the Hubble Ultra Deep Field, which is about as far out as the Hubble can go. And in the secular view, they believe that as you're looking farther out into space, it's like looking back in time because they believe it took the light a long time to get from there to here. Now, I would reject that. I'm not going to get into that tonight, but we can actually get the light here instantly. There's ways to do that. Einstein wrote about that. I've written about that. But in any case, for the sake of hypothesis, the secular view, we're seeing those as they were billions of years ago. And if you go back far enough, if you go back to a distance that corresponds to a time close to the Big Bang, there shouldn't be any galaxies because they hadn't had time to form yet. In the secular view, the universe starts with just energy, and then it takes time for stars to form and collect into galaxies. And so if you look into space far enough, you ought to look back to a time where there were no galaxies. And they didn't see that with the Hubble Deep Field. They saw billions of galaxies. And so we need a better telescope that can go. Apparently, galaxies formed earlier than we thought, and so we need a telescope that can go out even deeper into space. That was one of the motivations for building the James Webb Space Telescope. I won't go into the details, but suffice it to say, it is designed to peer deeper into space than Hubble can. And it is a brilliant design. The people who designed this, my hat's off to them. It is an amazing telescope. Well worth your $11 billion in tax money. So thank you for your support. Anyway, the secularists made some predictions about what they were expecting the James Webb Space Telescope to find. Because it can look out so far, close to the Big Bang, they were expecting that they should find fewer and fewer galaxies as you get closer to the Big Bang, because you're looking back in time in their view. And beyond a redshift of 14, redshift corresponds with distance. The farther away something is, the more redshifted it is. I won't go into that. But beyond a redshift, which is a distance of 14, you really shouldn't see any galaxies because that corresponds to a time less than 350 million years after the Big Bang. And it's supposed to take galaxies that long to form. So you shouldn't see any beyond that distance. Makes sense in their view. And the farthest galaxies they do see ought to be babies. Because the first galaxy, the idea is galaxies form really small and then they gain mass over time as they collide with other galaxies and absorb each other. So the farthest galaxies should be baby galaxies and therefore very low mass, clumpy and irregular because it's supposed to take time for them to smooth out to these beautiful spirals. And they were expecting the farthest galaxies would have no heavy elements, things like oxygen and carbon, because the Big Bang can't produce those. The Big Bang can only produce hydrogen and helium, a little bit of lithium. And therefore, what should the first stars be made of? Hydrogen, helium, a little bit of lithium, nothing else. And then those stars, some of the heavier of those stars are supposed to make the heavy elements in their core. And when they explode, they contaminate the universe with the heavy elements. And then the next generation of stars has heavy elements then. But the first generation shouldn't have any. And those would be called population 3 stars. Those haven't been discovered yet. They were hoping the James Webb would find those. Okay, you got their predictions? Fewer galaxies as you go out, and none beyond a redshift of 14. The ones you do see that are far away, babies, low mass, clumpy, and no heavy elements. I don't believe in the Big Bang, so I thought I better make some predictions too, because I'm confident that biblical creation is true. And I'm confident enough I was willing to put my predictions out there before James Webb had taken any observations. So back in January 2022, I made some predictions too. And mine are basically the opposite of what the secularists were expecting. Because I don't believe we're looking back in time. So I believe we'll see lots of galaxies at great distances, even beyond a redshift 14. Because I don't believe that galaxies form. I believe they were spoken into existence by God. And I don't see any reason why he would stop at redshift 14. So I think they keep going out. Maybe infinitely. So lots of galaxies at great distances, even beyond redshift 14. And I don't believe in baby galaxies. Now, I should point out, God did make a range. Galaxies come in a range of sizes. But I would expect that range would be the same here as it is out in distant space. So I'm going to expect that they're going to find fully formed massive galaxies, even at tremendous distances, comparable in mass to nearby galaxies. I don't believe that galaxies evolve over billions of years. God made Adam and Eve as adults. I think he made the galaxies as adults. Okay? And then I think those farthest galaxies will have heavy elements in them. Why? In the secular view, the universe starts with just hydrogen, helium, and lithium, and then the stars make the heavier stuff. I know the opposite is true. I know that the heavy elements were made first because, according to Scripture, in the beginning God made the heaven and the earth. The earth was without form. The Spirit of God was hovering over the waters. So on day one, earth had water on it. Water is H2O. That's oxygen. Oxygen's a heavy element. Stars are made on day 4. So I know the heavy elements existed before the stars. You see how I reasoned that? Okay. So I'm predicting the farthest galaxies will have heavy elements. And here's the real fun one. I was confident enough. I'm confident in Scripture, which is why I put these predictions out there. I was so confident that that the secular predictions would be wrong, that I also predicted how they would respond when they're proven wrong. Okay? This is my prediction. Because they're going to find galaxies way out farther than they were expecting. Rather than give up the Big Bang, they'll just say, well, I guess galaxies formed much earlier than we previously thought. And so there's my prediction. Webb discovers that galaxies formed much earlier than previously thought. Okay, that's my prediction of what they'll say when their predictions fail. And you can read about that. It's on our website, Biblical Science Institute. I published that on January 21st, 2022. That was before the James Webb Space Telescope had taken any data. It did not report its first data until July that year. So they pointed it out at a deep section of space, really far away. Did they find very few galaxies and none beyond a certain distance? Here's what they found. Galaxies upon galaxies upon galaxies upon galaxies at tremendous distances. And some of those are beyond redshift of 14. Some of the reports, there's different ways of estimating the redshift. There's a more thorough method, and there's a quick and dirty method. I won't get into the details, but some of these have been estimated to have redshifts 16, 17, one of them 20, way beyond it. So what are the results? Lots of galaxies at great distances, even beyond a redshift of 14, way more than they were expecting, and at further distances. Again, out to a redshift potentially of 20. That's using the quick and dirty method. They'll confirm it later with the more accurate method. Did they find baby galaxies? No. The farthest galaxies were fully formed, massive, and well-structured. We found spiral galaxies out there, even barred spirals, which are not supposed to form for like 6 billion years. What about the heavy elements? They found heavy elements in these galaxies, oxygen, carbon, things like that. Isn't that interesting? So the secularists were wrong about that. We creationists were right on that. Anybody who says, well, creationists don't make predictions about scientific discoveries, there's 3. What about my prediction of how they would respond? I predicted they would say, Webb discovers that galaxies formed much earlier than previously thought. Here's how they responded. Galaxies started forming much earlier than many astronomers previously thought. You can look that up. That's UConn Today, August 9, 2022. There it is. There's the record. Here's another one. Massive galaxies formed earlier in the universe than previously known. That's Nature News, July 27, 2022. Evidence is building that the first galaxies formed earlier than expected. Sky and Telescope, January 10, 2023. You can look those up. There's many others, too. I was trying to find one where they worded it exactly the way I did, but that's close enough, I think. So pretty neat. The universe declares God's glory. It really does. And I love the way the Bible describes. I mean, each one of those is a galaxy with hundreds of billions of stars in it. And I love the way the Bible describes the creation of all those galaxies. It's summed up in this little phrase, He made the stars also. Isn't that neat? Such power there. The universe does declare God's glory. Well, what about the basics of astronomy? People have said the Bible's not an astronomy textbook. I agree. Astronomy textbooks, we have to update them every few years when we learn we got some things wrong. The Bible will never have to be updated because God got it right the first time. And because the Bible's the Word of God, when it touches on astronomy, it's right, as when it touches on any subject, it's right. Yeah, and there are rules for interpretation. I understand that. There's hermeneutics. I'm familiar with that. But the Bible is right when it discusses the basics of astronomy. What I think is interesting is that this has always been the case, even when the secular experts of the time period disagreed. There are things that the Bible says that today we'd say, yeah, the Bible's right about that regarding astronomy, that when it was written, the experts of the day would not have agreed with it. Like, for example, the shape of the earth. The Bible indicates that God made a spherical earth. It says in Job 26:10 that he, that is God, has inscribed a circle on the surface of the waters at the boundary of light and darkness. What's he referring to there? The boundary of light and darkness, that's where evening and morning are occurring. It's what astronomers call the terminator, okay? And it's on the face of the waters because Earth's surface is mostly water. And the Bible indicates that shape is a circle, that God inscribes a circle on the face of the waters at the boundary between light and darkness. And if we rotate it around, you can see it is a perfect circle. The only shape that has a circular terminator all the time is a sphere. It's the only one. And God mentions that in Job 26:10. So it teaches that the boundary between light and darkness is a circle, and that's only possible on a sphere. And I think that's interesting because Job was written, we think, around 2000 BC. We think it's actually the oldest book of the Bible to have been completed. Moses hadn't written Genesis yet. But in any case, I think that's interesting because as far as I can tell, all pagan cultures at the time believed the earth was flat. Isn't that interesting? It wasn't until around 500 BC that the Greeks finally came around and said, oh, yeah, the earth probably is round. And it wasn't considered proven until around the 300s BC. Aristotle was one of the earlier folks to demonstrate that the world is round. And he had good arguments for it. He pointed out that when the ship is coming to shore, you see the top of the ship before you see the bottom because of the curvature of the waters. Pointed out that when there's a lunar eclipse, as there was a couple of days ago, we couldn't see it from here, but when the earth casts its shadow on the moon, it's always round, no matter what the orientation of the sun and the moon are. And that demonstrates that the earth is round. It can't be a flat disk because then at some times it would cast its shadow as a straight line, if you see what I'm saying. So during a lunar eclipse, and I've seen many, the earth's shadow on the moon is always a circle. And so, but I think it's interesting. There would have been a time when people would have said, that passage in Job is just wrong. There's no way the earth is a sphere. That's impossible. We know it's flat. They were wrong. The Bible was right. The nature of the earth floating in space. Job 26:7 says, God hangs the earth upon nothing. Isn't that wonderful? A beautiful poetic description of the nature of gravity. I think that's delightful. And again, that was around 2000 around 2000 BC, so 4,000 years ago, that Job wrote that. And it wasn't until much later that the Greeks figured out, the earth probably does float in space. Okay. And so I think that's pretty neat. We have pictures of it now confirming that. It's absolutely wonderful. The expansion of the universe, that God stretches out. Isaiah 40:22 states that God stretches out the heavens like a curtain, spreads them out like a tent to dwell in. What does that mean? Well, apparently God made the universe with some size, and then he stretched it out since then. He stretched out the heavens. And that would have been disputed up until at least the 1600s. Most astronomers believed the universe was static and unchanging. And it wasn't really until the 1920s that Edwin Hubble and others demonstrated that galaxies are all moving away from each other. And that indicates the entire universe is being stretched out or expanded. That's called the Hubble law. That was published in the late 1920s. So, and it's really neat because to discover that the galaxies are moving away from each other, you need modern technology to discover it by scientific means. You need a telescope to be able to see the galaxies, and you need a spectroscope to be able to split the light up and measure their redshifts. And the telescope wasn't invented until the 1608 was the invention of the telescope. The spectroscope was later. So that required modern technology, and yet Job spoke about it 2000 BC, almost as if he had a little divine insight into that issue. That's kind of neat. So there it is. Now, I have to clarify this because some people think, well, if the galaxies are all moving away from each other and you run the movie backwards, don't they go back to a point? If the universe is expanding, doesn't that mean it exploded into existence 13.8 billion years ago? And the answer is no. Just because something's expanding doesn't mean it exploded into existence 13.8 billion years ago. Some of you are expanding a bit. That doesn't mean you exploded into existence 13.8 billion years ago. Okay? We understand that. This means you're bigger than you used to be. God made the universe with size, and he stretched it out since then. Some people have said, oh, doesn't this at least give evidence of the Big Bang? Didn't the Big Bang predict this expansion? And there it is? No. This expansion was discovered in the late 1920s. The Big Bang was invented as a secular explanation for that expansion. The Big Bang was 1931. George Lemaitre, the inventor of the Big Bang, he knew the universe was expanding, and he was trying to come up with a naturalistic explanation for it. He did believe in God, but he believed that you should leave God out when you're doing science and methodological naturalism, which is not a biblical philosophy. But anyway, conservation of mass and energy. This is something the Bible teaches, that the amount of stuff in the universe is constant because God ended his work by the seventh day, and all things were made by him. And that tells us no new material is going to come into existence, right? Because it would either mean God is still creating new material, which he's not, because God ended his work of creation by the seventh day. God's still working, but he's ended his work of creation of this universe by the seventh day. So nothing new is going to come into existence. Or it would mean something can pop into existence apart from God, which cannot be because all things were made by him. So no new material is going to come into existence. And nothing's going to cease to exist because Christ upholds all things by the word of his power, and in him all things consist or hold together. Christ maintains that which he created. He allows it to change. You can change form of energy and mass and so on, but it's not going to, you can't make brand new material, nor can you destroy material that exists. You can only change its form. And that's interesting because Genesis, we think, is around 1400s BC, somewhere around there. That's when the Exodus occurred. And then the other verses are New Testament, so they're all first century. So these were written thousands of years ago. The idea that the amount of stuff in the universe is constant, these were thousands of years ago. The Greeks would not have agreed with that. The ancient Greeks believed that stuff could come into existence and stuff could cease to exist. They did not believe the conservation of mass energy. In fact, it wasn't until the 1700s that the conservation of mass was discovered by scientific means. Conservation of energy is 1842. Shared credit between Mayer and Joule. I've read James Joule's writings on this, though, and it's clear that he believed the Bible. And when he discovered conservation of energy, he said, well, it makes sense because God's not making any new material. So it's kind of interesting. He was positively influenced by his biblical worldview. And then the equivalence of mass and energy is Einstein. That's 1905. So now, does this preclude a creative miracle? Can God temporarily make something? Can he multiply fish and loaves? Yes, of course. But the point is, the norm is that God is not making new material today. Innumerable stars. The Bible describes Abraham's descendants as being as numerable as the stars of the heavens and the sand which is on the seashore. And that is a beautiful analogy for an unlimited, or at least a humanly uncountable number. And in fact, the Bible says so in Genesis 32:12. It says, which is too great to be numbered. So the number of stars and the sand on the seashore, a humanly uncountable number. Pretty neat. And that's a good analogy. But I wonder if, I don't know that this happened, but there was a time, I do know that there was a time in the Middle Ages when astronomers believed there were exactly 1,022 stars. What? It's true. And the reason was the Greek astronomer Ptolemy had cataloged, he lived around 100 AD. He had cataloged 1,022 stars. Now, Ptolemy never claimed that his list was exhaustive. But there was a philosophy at the time that everything worth knowing had been discovered by the Greeks. And so it was very common to believe there were 1,022 stars. And you might say, well, then the Bible's wrong, right? Because I can count to 1,022. It'd be tedious, but I could do that. You could do that in a day. Okay? So it's not too great to be numbered. Now, the sand on the seashore, yeah, that's innumerable, but not the stars of heaven. And then the telescope was invented in 1608. Galileo made his own in 1610 and pointed up at the Milky Way. Oh, that cloudy band, that's hundreds of billions of stars. And you can't count to 100 billion in your lifetime. And that's one galaxy. I think there's at least 100 billion galaxies in the universe, more now that the James Webb is discovering, more at greater distances. So it's a wonderful analogy. The Bible was right. Have we learned the lesson of history? Whenever the experts of the day have disagreed with the Bible's always turned out to be right. The experts of the day, they're what we call wrong. Have we learned that lesson? I hope you have. Not everyone has. Because there's some people that say, yeah, I'll grant the Bible somehow got lucky on all those issues. But we know it's wrong about the age of the cosmos. So I want to talk a little bit about that. Because the Bible is right when it addresses the age of the universe and everything within it. The Bible indicates God created in 6 days. If you were here yesterday morning, I talked about that and showed, yes, those are ordinary days, 24-hour Earth rotation, each bound by an evening and morning. The Bible is very clear about that. They're the same as the days of our work week. In fact, our work week is based on God's creation week. That's why we have a 7-day week. And God made everything in the span of 6 days, the heaven, the earth, the sea, and all that's in them. That would include the stars, galaxies, everything. Most of the stuff we're looking at made on day 4, that first Wednesday, interestingly. Now, secularists say that's nonsense. They believe in evolution for the most part, and because of that, they'll never give up the idea of deep time, the idea of billions of years, because they need that for evolution to sound plausible. Because even evolutionists would have to admit, 6,000 years, yeah, you're not going to turn a frog into a prince in 6,000 years. It takes millions of years to do that. So there you go. Now, what I want to do is show you evidence that's inconsistent with the secular position, but I have to explain a little bit what we're doing here because a lot of people misunderstand this. The best way, really the only way, to refute a worldview issue is with what's called an internal critique. And that is where I temporarily accept the secular assumptions as a hypothetical only. I don't actually believe them, but I accept them as a hypothesis and then show that they lead to an inconsistency. This is a reductio ad absurdum. That's a very powerful way of refuting faulty thinking using logic. So I'm going to assume things I don't actually believe in to show that they lead to an inconsistency, because it turns out all old Earth arguments are predicated on at least 2 assumptions. They are naturalism and uniformitarianism. Naturalism is the belief that everything that happens within the laws of nature, and therefore there's no God, or if there is, he doesn't do anything, or he's within nature. So that's naturalism. I reject that. I believe in a supernatural creation. It goes beyond the laws of nature, which merely show the way God normally upholds his world today. And then uniformitarianism. Uniformitarianism is the belief that present rates and conditions are reflective of past rates and conditions. Okay, and so if something isn't happening today, it never happened. And uniformitarianism would reject a worldwide flood, for example, because a worldwide flood's not happening today, therefore it never did. I reject that thinking. So to be clear, I reject both of those hypotheses. But what I'm going to do is temporarily assume them to show that even when I assume them, there's many situations where the universe cannot be as old as the secularists believe, using their own assumptions. You see how powerful that way of arguing is? Very powerful. It's endorsed in Proverbs 26, 4 and 5. It works very well. So, for example, the internal heat from Jupiter. Jupiter actually gives off twice as much energy as it receives from the sun. So it gets 1 unit of energy from the sun and gives off 2. Gets 1 unit, gives off 2. Takes 1 in, spends away 2. Kind of like our federal government, right? There you go. And like our federal government, it can't do that forever because eventually you run out of energy. Okay? So think about that. It's giving off twice as much energy it gets, therefore constantly losing energy. It's the same way as if you've just microwaved a potato and you bring it out, you can feel the heat coming off of it, right? That's radiative and convective transfer. You can feel that. You get a telephone call and, oh, it's business. And you come back 2 hours later. Is it still warm? No, it's cold. It's room temperature. It's radiated away all of its energy. It doesn't take a long time. Now, Jupiter's doing that. It's like the hot potato that's giving away energy, and it's been doing it for 6,000 years because it's a pretty big potato, so it can radiate for a long time. But if it were 4.5 billion years old, it should be room temperature. It should be in equilibrium with the rest of the universe at that point, and it's not. And so that's an indication that Jupiter is not billions of years old. The problem's even worse for Neptune. Neptune gives off 2.6 times as much energy as it receives from the sun every second of every day since creation. Now, Jupiter's 10 times the size of the Earth. Neptune's only 4 times the size of the Earth, and it's got a bigger heat excess than Jupiter. That's interesting. It doesn't work over billions of years. It doesn't work. But it makes sense if they're thousands of years old. Now, secularists could say, oh, but the rate was very, very different in the past, but then they're rejecting uniformitarianism, you see. So anyway, Earth's magnetic field is actually decaying. Earth's magnetic field is caused by electrical current in the core. And maybe you've made a magnet, maybe when you were a youngster, and you take a coil of wire and touch it to a battery, and you can pick up nails and stuff. It's kind of neat. That's how you make a magnet, is electrical current. The Earth has that in its core, but electrical current runs down with time. Batteries run down with time. And so the magnetic field has been decaying since creation. And we can measure that today. We find that in the last 100, 150 years, the magnetic field strength has dropped. The magnetic energy has dropped. You run that back to creation. We think it's an exponential decay. That's what we'd expect on the basis of physics. The magnetic field would have been about 20 times stronger than it is today, back at creation about 6,000 years ago. But if you continue to run that backwards, it gets really steep. And if you run it back 60,000 years, the magnetic field would have been so strong it would rip the iron out of your blood. In fact, you'd probably rip the atoms of your body apart. It would be stronger than that of a neutron star. You can't have that. Life can't exist under those conditions. And we're not talking billions or even millions of years. We're talking 60,000 years. That puts a tight constraint on Earth's magnetic field. And secularists say, well, it was different in the past. It was, it's oscillated and so on. But again, they're rejecting their own assumption of uniformitarianism, by which they get the millions of years in the first place. It's not just Earth's magnetic field. Jupiter has a whopping big magnetic field. That you can even have aurora borealis on Jupiter. That's what you're seeing there at the top of that picture. It's been enhanced for you, but that's it. And that's caused by magnetic activity. So Uranus and Neptune have strong magnetic fields. Interestingly, the secularists were astonished to find that Uranus and Neptune had strong magnetic fields because they're primarily ice. Ice doesn't hold magnetic charge very well, and they're not that big. They're 4 times the size of the Earth, but based on their composition, they should be magnetically dead if they're 4.5 billion years old. But interestingly, a friend of mine, Russ Humphreys, who's a PhD physicist and a biblical creationist like myself, he actually predicted the magnetic fields of these planets based on their biblical age of about 6,000 years. He did that back in the early 80s, and then in 80, and he published it. You can look at it. You can look at his result. And then in 86, Voyager 2 flew past Uranus for the first time and measured its magnetic field, and Dr. Humphreys was right on. It was right in the range that he had predicted. And then in 1989, it flew past Neptune and measured its magnetic field, and Russ Humphreys was right on. Isn't that interesting? See, you want to get the right answer? Start with the Bible. Start with the Bible. Lunar recession. This is interesting. The moon is actually moving away from the Earth due to tidal forces. Isn't that interesting? You see, the moon induces tidal bulges on the Earth because its gravity pulls on the Earth's ocean, and that pulls that ocean away from the Earth. And if you're wondering, how do you get a bulge on the other side? Well, the moon's pulling the Earth away from that ocean. That's the way to think about it. So it kind of stretches out the Earth like that. So that's how you get tidal bulges. And but the Earth is rotating counterclockwise if you're looking over the North Pole. And those tidal bulges, therefore, they get ahead of the moon because the Earth rotates faster than the moon orbits. The moon's orbiting the same direction, but the Earth's rotating much faster, right? And so what happens when the tidal bulges, they're pulling forward on the moon because they're always ahead of it. What that causes is the moon to move away from the Earth. That's a little counterintuitive. But if you've ever played with a gyroscope, you know that when things are spinning, the way they behave is a little bit counterintuitive. But the astronauts, for example, on the space station, if they want to go into a higher orbit, they thrust forward. And they have to do that every now and then because the space station drops due to the slight drag. There's a little bit of atmosphere where it's at. Anyway, so if you think about that, the moon is moving away from the Earth, and we've been able to measure that. We left reflectors on the moon when people did walk on the moon. We left reflectors there, and we can bounce lasers off those and by timing it, we can get the distance to the moon within a fraction of an inch. And so we know that the moon moves away from the Earth at a rate of about 1.5 inches a year. We've been able to measure that since the late 60s. And what that means is if you run the movie back in time, the moon would have been closer to the Earth, right? And you have to do the math right because if it gets closer, then the tidal bulges would be bigger and the rate would be faster, and they get bigger, faster, bigger, and so on. Okay, you have to do the math properly. The uniformitarian assumption would be that the constant is not the rate, but the rate at which it changes is constant. And so if you do the math, and I've done the math, the Earth and Moon would have been touching at a hypothetical 1.45 billion years in a hypothetical past. Isn't that interesting? So they can't be older than that. And you understand that's an upper limit because you can't get closer than 0, right? So that's an upper limit. And you say, well, okay, yeah, that's a long time, 1.45 billion years. Yeah, but secularists believe the Earth and Moon to be 4.5 billion years old. See the problem? It's inconsistent with their own estimate of the age. Comets are made up of ice and dirt, and they orbit the sun in elliptical paths. They remain far out where their ice remains frozen, and they come close in and whiplash back out. And when they get close to the sun, you think ice close to the sun, that can't be good, and you'd be right. It vaporizes the icy material, blasts it into space. That's what the comet's tail is. That's material being vaporized and blasted away from the comet. So every time you see a comet, it's getting smaller. It's losing material. And we can measure the rate at which it's losing material. And we know how much material's there. The nucleus of a comet is just a few miles across. So we can do the math, and we can estimate that a typical comet can last no more than about 100,000 years maximum. Isn't that interesting? Some comets don't even last that long. I've seen comets. I use the SOHO spacecraft in my doctoral research, and it has an instrument on it that can detect comets when they get really close to the sun. I've seen comets that have gone behind the sun, and that's it. They've been completely vaporized in one visible pass. I've seen comets that do not exist anymore, like Comet Ison that was a few years ago. It's gone now. Anyway, comets don't last millions of years, let alone billions, but we still have them. We still have them, and a lot of them. My secular colleagues have said, well, there must be, they can do the same math I can do. And so they've said, well, there must be a comet generator that produces new comets, which they call the Oort cloud. If you ever heard of the Oort cloud, that's an attempt to rescue the billions of years from a solar system that doesn't look like it's billions of years old. But if we're honest about it, there's no observational evidence of an Oort cloud. It is a hypothesis only. As far as I can tell, comets are just an evidence of a young solar system. There's always a rescuing device. I don't want to pretend that there isn't. Pluto. Oh, this was exciting. Back in 2015 when we finally got a close-up of Pluto thanks to the New Horizons spacecraft that flew past that little dwarf world in 2015. And what they were expecting to find was a cold, dead world completely covered with craters because Pluto is, on average, 39 times farther from the sun than Earth is. It is far away. It doesn't get much sunlight. The sun would be 1,000 times fainter at that distance. It doesn't get much light from the sun, much heat from the sun, and it's small. Pluto is only 2/3 the size of Earth's moon. And if you're wondering why it got demoted, that was one of the major contributors. It was much smaller than we originally thought it was. It's itty-bitty. And being that small, it can't retain heat very much. It's a small potato that doesn't last very long, right, in terms of emitting heat out into space. And there's a lot of other objects out at that distance that orbit close to Pluto, and over billions of years, a lot of them should have hit Pluto's surface, and so it should be completely covered with craters, and with no internal heat, no tectonic activity, no geology to reset the surface. It should be completely cold and dead, covered with craters. And so it was astonishing when they found a few craters on Pluto, but not as many as they were expecting, and some places that have no craters, like that large cream-colored region that you see up there, there's not a single crater in there. That's amazing. If it's been orbiting for billions of years without anything hitting it, and it has this weird tessellation pattern, like there's been recent geology, but that can't happen if it's been frozen and dead for 4.5 billion years. There's evidence of geology. There are mountains on Pluto. That was totally unexpected by the secularists, because mountains require geology. They require internal heat to uplift them. There they are. They're made of ice. Ice is as hard as rock at that distance, but they're as tall as the Rocky Mountains. That's pretty spectacular. Pluto's largest moon, Charon, same kind of thing. Some craters, but valleys, mountains. Interesting features. Spiral galaxies can't last billions of years because they rotate differentially, meaning the inner portions rotate faster than the outer portions. To be clear, the linear speed's about the same, but the inner portions have much shorter trip, okay? So stars near the interior, they zip around like that. Stars near the exterior, they take much longer. And if you think about that, what would happen over billions of years? That spiral would get tighter and tighter, wouldn't it? I ran a simulation based on the actual measured velocities of those stars And I ran it out for many millions of years because these galaxies are supposed to be 10 billion years old. So I thought, what would a galaxy look like if it were 10 billion years old? So based on the actual velocities of these stars, I ran a simulation. The number at the bottom is the number of millions of years in the future. Check it out. That's what happens. And so after you get to about 100 million years, that spiral is tight. And by the time you get to 300 million years, it's tighter than any galaxy we've ever seen. We've never seen a galaxy that has a spiral structure that tight. I've looked at hundreds, if not thousands of galaxies. None of them look like that. But we're not even out to 1 billion years yet. They're supposed to be 10 billion years old. I was made aware of this in grad school. These secularists refer to it as the spiral winding problem. I refer to it as the spiral winding feature. It's an indication that galaxies are not billions of years old. You might notice that galaxies have a lot of stars in them. Some of them are blue. Blue stars can't last billions of years either. Blue stars are an indication of a youthful universe. Blue stars are the most massive stars in the galaxy, but they're also the most luminous. They expend their fuel really quickly. So that means they have a lot of fuel available, but they burn it up really fast. They're kind of like an SUV. Big gas tank, very poor gas mileage. So they can't go very far in time until they burn out. And the brightest, bluest stars can last no more than 1 million years, it's estimated. But there they are, like Orion's belt. Isn't that pretty? So a lot of stuff like that. And I don't intend to deceive you into thinking that secularists don't have explanations they've tried to invoke for these things, but most of them involve a violation of uniformitarianism, which is the very assumption by which they get the billions of years in the first place, you see. So that's a problem. Finally, the uniqueness of the Earth. The Earth really is a special planet. It's the planet that God formed to be inhabited. And the Bible says that in Isaiah 45:18. He's the God who formed the earth and made it. He established it and did not create it a waste place, but formed it to be inhabited. And the earth has all kinds of life features on it because it is formed to be inhabited. It's at the right distance from the sun to receive the proper amount of heat and light. To keep water in a liquid state, it has abundant liquid water on its surface. Water is actually a fairly common molecule in space, but it's almost always either vapor or ice. It's rare to find in a liquid state. And so Earth's the only place for sure where we found it in a liquid state. But it is a common molecule. But it's covering the Earth's surface, and we think water is necessary for life. So that's a nice feature there. Earth's neighbors, not designed for life. They are. I'm glad God made the moon. It's wonderful. In fact, it helps life on Earth because it keeps Earth's oceans from stagnating. It causes tides, and that's helpful. But it's not designed for life on its surface. Buzz Aldrin, who walked on the moon, referred to it as a magnificent desolation. I think that's a wonderful term for the moon. But you can't live there. There's no air to breathe. There's no liquid water on the surface. The temperature between day and night is hundreds of degrees. The astronauts had to bring a little bit of Earth with them to survive for a few days on the moon. Some air from the Earth and water and food. Earth's neighbors, wonderful. I'm glad God made these planets. They're fun to look at in a telescope. They're not designed for life. Mercury and Venus, way too hot for life. Mars, too cold for life. Earth, just right. It's got like Goldilocks and the Three Bears, right? So Earth's just right for life. And that raises the question of extraterrestrial life. And I don't believe that we'll find extraterrestrial life out in space. A lot of that's driven by the secular expectation that since life evolved on Earth, and hey, it's a big universe, there's probably other places where the chemistry's right. Life probably evolved there too. And so the secularists expect to find extraterrestrial life. I don't, because God formed the Earth to be inhabited. And I'll grant the Bible doesn't say, and he didn't do that with the other planets, but that seems to be the implication. If you think about it, Earth is made on day 1 of the creation week. Everything else, day 4. All the other lights in the sky, that would include the stars, it would include the other planets as well. The kochab, the Hebrew word, would include other planets as well. They're all made on day 4. Earth really is special. And if you have intelligent life out in space, you got some theological issues you're going to have to think through, right? Because if you have Vulcans and Klingons out there, they can't be saved. You realize that? It's because we're related to Jesus. We're all of one blood. We're all descended from Adam, and so is Jesus. That makes him our blood relative. That's why he can be our kinsman redeemer. But Lieutenant Worf, he's out of luck because he's not descended from Adam. He's not related to Jesus. He can't be saved, unfortunately. I like Worf, but he can't be saved. I'm sorry. And some people say, well, maybe Jesus went and became a Klingon and died for them. The Bible says he died once for all. He was raised incorruptible. He'll never die again. So you see the issue there. But there is a lot of hype. regarding extraterrestrial life, and a lot of it is a vindication of evolution. Life evolved here, probably evolved elsewhere, right? That's the thinking. But a lot of it too, if you think about it, because I've had the opportunity to ask my secular colleagues, and they're brilliant people, there's no doubt about that. Why are you so interested in finding life out in space, intelligent societies? The assumption is, and you'll see this in a lot of the movies, is that extraterrestrials will be far more advanced than we are. And there is that need in us to look up and say, there's something greater than us out there, greater in intelligence. They would probably have incredible technology. Maybe they could cure our diseases. They would probably have the answers to life's problems, the questions that we ask of existence and so on, because they're more advanced and they've thought of these things. Maybe they've even figured out how to beat death and live forever. And if you think about it, those are all the things God provides, right? You reject God, and that need comes out in other ways. And so I would suggest that perhaps the hype for extraterrestrials is those who reject the biblical God, but still have that need for companionship with a superior being who can answer our questions, who can cure our diseases, who can give life meaning. So that's something to think about. But it is interesting, of all the planets out there in the universe, this is the one where God became a man and died our death in our place. That's pretty awesome. This is the planet where God walked, and it wasn't Mars, it wasn't Saturn, it was Earth. One of the astronauts who walked on the moon, Jim Irwin, he later became a Christian, a very devout Christian, a biblical creationist. I never had the opportunity to meet him, unfortunately, but he sounded like a neat guy. But there's a quote he said at one point, and I'm paraphrasing, but he said something to the effect of, the amazing thing is not that man walked on the moon, but that God walked on the earth. And I think that's a good sentiment, that God cared enough about you, the God who spoke those hundreds of billions of galaxies into existence by the breath of his mouth, visited this world, died in our place, rose again, proving he is who he claims to be, and has offered salvation for anyone who repents and trusts in him. I think that's awesome. So I think we've seen that the secrets of the cosmos do confirm the Bible. The book that I've written that covers all these topics, except the James Webb Space Telescope, because that's brand new. Taking Back Astronomy. There it is. And then we do have an older version of this presentation, Astronomy Reveals Creation, on DVD. And then don't forget about the ultimate proof of creation as well, to give a bulletproof argument for biblical creation. If you want to learn how to find some of these things that we looked at this evening, Stargazer's Guide to the Night Sky. It's just a book on how to better enjoy the night sky from a Christian perspective. It'll show you where these things are at, how to identify the stars and constellations, when the next meteor shower is going to happen, that kind of stuff. If you want to get a telescope, what kind you might want to get and how to use it. But even if you don't have a telescope, there's a lot of stuff you can see naked eye or with binoculars. You can see Jupiter's moons with binoculars. Yeah, or Saturn's rings. You just got to know which one's Saturn. That's where the book's going to help you. So there you go. Stargazer's Guide to the Night Sky. Created Cosmos takes you on a tour of the universe from a biblical perspective. That's the planetarium show I wrote for the Creation Museum. It's really kind of a 23-minute movie. It just takes you through the universe. So it's a blast. Physics of Einstein, if you've ever wondered about black holes and time travel, and what about distant starlight? We didn't cover that this evening, but it's all covered in that book. And I won't go through all of these. But I will remind you, Worlds of Creation, too, is another fun one. That takes you on a tour of the solar system from a biblical perspective and shows you how each of the worlds of creation declares God's glory and is not the result of chance or a collapsing nebula. Secret Code of Creation shows you how God has built incredible beauty into an aspect of creation most people have never even thought about. And there is no secular explanation for what you're going to see on that. It is devastating to any non-Christian worldview. We have that on Blu-ray as well, because it's quite beautiful. And we have a book that goes along with that. You might leaf through that book. Every picture you see there was not drawn by human hands. It's artwork of God, and there is no secular explanation for it. It's really amazing. The best of our books together, again, you can get for 20% discount, the best of our DVDs for 20% discount, or our library pack for 30% discount. Yeah, that's for tonight only. And don't forget our children's books and to sign up for our free monthly newsletter. We're going to take a 10-minute break again. This will be your last opportunity to purchase the resources because I think we're going to do a Q&A next. But during the Q&A, my team will be packing up the resources. So get them now, okay? Thank you very much. God bless.